Hello guys, welcome once more to the class online, and we shall be looking at JAMB Physics 2020 question number 31 to number 35 in this video. Okay, if you are ready, I'm also ready. Now don't forget to like this video if you really enjoyed the video, and to tell your friends about us so that we can get more things across to you from time to time. Remember, we can only reach you as you like the video, so that we can reach you from time to time and help you in your journey of learning physics. So let's get to number 31. The lower and upper fixed point mark on a mercury in glass thermometer are 210 meters apart. The end of the mercury column in the tube is 49 millimeters above the lower fixed point in the room. What is the temperature of the room in degrees Celsius? Now this one is simply a question that is asking about thermometer, and you know there's only one formula to use when you are tackling questions on thermometer, and this is the formula. This formula says you must take into consideration the upper steam point and the lower point. That's the steam point and the ice point. So for every question on thermometer, you must take into consideration the steam point, that's the highest point, and the minimum point, that's the lowest point, that's the ice point. Okay, so this one says that you have a thermometer that has 210 meters apart. That means all the gap between the lowest and the highest is 210, right? So that is 210 meters apart. That actually should have been millimeter apart. Okay, that should have been millimeter apart. So that should be 210 millimeter to 0 millimeter. Okay, so then it has a midpoint of 49 millimeter. Okay, now the question then gave you to find what the temperature will be in degrees Celsius. Definitely, you know, degrees Celsius temperature is between 0 degree and 100 degree. That's for boiling water and for ice block. Okay, so normal temperature is between 0 degree. That's for water. That's ice and boiling water. That's steam. That means what I'm saying is that water boils at 100 degrees Celsius and then water freezes at 0 degrees Celsius. So normally for degrees Celsius it is between 0 and 100, but for the other thermometer that we have in this question, we have 210 millimeters apart, and then we have the midpoint at 49. So we are trying to find the midpoint of in degrees Celsius that 49 millimeter will be. So we have 49 millimeter in the other thermometer, but what will it be in degrees Celsius? And it is always in this format. If you know this format, then you've understood how to tackle questions that are related to temperature in JAMB. Okay, so let's move to the question now. The next thing you do is to say 49, that's the midpoint, minus 0. Okay, then the largest point, 210 minus 0. Then for the temperature in Celsius, you have x minus 0, the same thing, then 100 minus 0. So you just solve that for that. 49 minus 0 is 49, 210 minus 0 is 210, then x minus 0 is x, then 100 minus 0 is 100. Then you cross multiply. So we have 210 x equals 49 times 100, that's 4,900. So divide both sides by 210, you have 4,900 divided by 210, x is therefore 23.3. Okay, so this is the format. The first temperature on the left hand side, then the other temperature on the right hand side. Okay, now once you arrange them, the maximum and the minimum below, then the maximum and the minimum, then the midpoint, you will now get it. This is the format they ask the question on thermometer, and this is the calculation on thermometer, and this is the way it always come out in this format. It might not be the same number, but it will be in this same format. Once you get this format, then you've understood questions on thermometer. Okay, so let's go now. Let's go to the next to check out the option that's right. Actually, we don't have any of the options correct, but the correct answer is 23.3. Now, that's not new with past questions. Most of the options might be wrong, but you just need to know how to solve it. And in my case, I just went for the option that is closest to the answer. But actually, the right answer to that question is 23.33, and that is the way to go. Okay, so let's go on now. Number 32 says heat is supplied uniformly at the rate of 100 watts to 1 times 10 to the power minus 2 kilograms of liquid for 20 seconds. if the temperature of the liquid rises by 5 degrees Celsius, then the specific heat capacity of the liquid is what? Now, this question is simply asking for specific heat capacity. Now, this is a topic in physics, and this topic has a formula. Now, if you've heard about it before, do you have any idea about the formula to use to find specific heat capacity? Okay, if you don't have any idea, then I will show you. Now, whenever you have a question on heat, specific heat capacity, now heat is a form of energy, but there's only one formula to know. Now, but in this case, you are not giving heat, you are giving power, and you are giving time. And you must know that if you have been given power and time, you have been given heat also. Whatever formula gives you power and time is trying to give you heat indirectly. So this formula didn't give me heat, but it gave me power and time. And I should know that heat energy is power times time. That's heat is just energy, and electric energy is power times time. So what I'm saying is that for me to get the amount of heat which they did not give me, but which they have given me indirectly, just multiply the power times the time. That's the power and the time, multiply them. That will give me 100 times 20, and that will give me 2000 joule. That is the heat. I've exposed what they were trying to hide, and I'm very good at that. So I like to expose that. So power and time multiplied is heat, okay, or is energy. And heat and energy, I'm saying the same thing. So let's go now. Now, whenever you have a question on specific heat capacity, there's only one formula to know, and the formula is H, that's heat, equals mc theta 2 minus theta 1, and those theta are actually temperature, okay? Now, m is mass, that's mass. Then C is specific heat capacity, while the H is my heat. And now in this question, I have found my heat as 2000 joule. My mass given to me in the question is 1 times 10 per minus 2 kilogram. Then my specific heat capacity is what I'm looking for. I don't know. Then my temperature is between is 5 degrees Celsius, right? So I have all my parameters set. Now going on from that formula, H mc theta 2 minus theta 1. Now this formula is very powerful, and I want you to know it by heart, because with this formula you can solve any question on heat. Okay, it's very key. Heat is always mc theta 2 minus theta 1. Where my m is mass, my c is specific heat capacity, my theta is temperature. Do you get that now? Now let's go on. Now this question says find the specific heat capacity. That means find C. So make C, turn the formula around and make C the subject. So that means m and theta 2 theta 1 will go under the H. So my C is there for H over m theta. That's the 2 theta is what I'm calling theta now. Now the 2 theta is what I'm calling 1 theta, because when you subtract them, you will get 1 theta. When you subtract theta 2 from theta 1, you will get 1 theta. So that's my C is there for H over m theta. Okay, now my C is there for 2000. That's my heat over m. My mass is 1 times 10 raised to the power minus 2. My theta, that's my temperature, is 5. So giving me 2000, okay, over 1 times 10 raised to the power minus 2 times 5. Giving me 20 times 10 raised to the power 2. Then I have minus 2 below. 5 times 1 is 5. Then I have 10 raised to the power minus 2. So I just made it minus 2 so that they can fuse easily. So that will give me 20 divided by 5. Remember, I said divide numbers separately. Then 10 raised to the power minus 10 raised to the power 2. The 10 raised to the power minus 2 below will go up and become plus 2. So giving me 20 divided by 5, that's 4. 10 raised to the power 2 plus 2 giving me 4. 4 times 10 raised to the power 4 joule per kilogram per Kelvin. And that is my specific heat capacity. So making my answer to be 4 times 10 to the power 4 joule per kilogram per Kelvin. That is the unit of specific heat capacity. Now, the most important thing in this question is just to know the formula of specific heat capacity. H equals mc theta 2 minus theta 1. Please don't forget that formula. It's very key. H equals mc theta 2 minus theta 1. Okay, so with that formula, you can solve any question on heat capacity. Let's go on now to number 33. Now, number 33. Number 33 says 2 drivers G and H are at depth 20 meter and 40 meter respectively below the water surface in a lake. The pressure on G is P1, while the pressure on H is P2. If the atmospheric pressure is equivalent to 10 centimeter square of water, then the value of P2 minus P1 is what? Now you have 2 drivers now, you know, pressure increase with depth. So what we have to do now is that if you have drivers in a river like this, like I have the picture there, a diver and a diver, all you have to do to get the value is just to divide them by the atmospheric pressure. That means what I'm saying is that you have been given a natural pressure for each of them. P1 is 20, P2 is 40. So divide each of them by the atmospheric pressure 10. So I just did the first one, P1 20 over 10, then the second one is 40 over 10, giving me 2:4. That is my ratio. Then they said put P2 over P1. So what I got is 4 over 2, and the answer automatically gave me 2. Don't forget that pressure is always divided over the atmospheric pressure. In order to get the original pressure, divided by the atmospheric pressure to get the original pressure, and that gave me 2:4. But the question did not say P1 over P2. The question said P2 over P1. So I will not say I will not say, sorry, I won't say 2 over 4. That would have been error, because I might want to say 2 over 4 because I'm saying with ratio 2:4, which is supposed to be 2 over 4. But the question said P2 over P1, which is supposed to be 4 over 2. So that will give me 2, and that is my answer. So my answer is 2, and that is option D. Now don't forget that. Don't forget the way it was solved. Now let's go to number 34 now. It says figure 6 represents a block and tackle pulley system on which an effort of W Newton supports a load of 120 Newton. If the efficiency of the machine is 40 degrees, then the value of W is what? Now this is a block and tackle pulley. Now there's one thing, this is a topic under machine, and when you are saying block and tackle pulley, you are to remember one thing, and that's most important thing to remember. You have been given, there was a statement in that question that said efficiency of the machine is 40 degrees, and the first thing to remember in this question is efficiency. Now the efficiency formula of any machine is always mechanical advantage, that's MA over the velocity ratio times 100. You must remember this formula. It's very, very important to answer any machine question. They most times ask about efficiency, and efficiency is the strongest formula in machine. Now efficiency is mechanical advantage over velocity ratio times 100. Now don't forget that mechanical advantage is always load over effort. So I broke it further. Efficiency is load over effort, which is mechanical advantage over velocity ratio times 100, right? Good. Now, for any block and tackle system or pulley system, you don't need to find the velocity ratio. You just have to count the number of ropes. Okay, what I mean is that, look at what I did there. Just go to that NB. I said take note, if you have any block and tackle system, to find the velocity ratio is just to count the number of ropes. That means I won't use the velocity ratio formula. I'll just say, how many ropes can I see there? I just counted it for you. 1, 2, 3, 4, 5, 6. 6 ropes. Okay, I counted the number of ropes. That is the velocity ratio, and that is how to go about it. If you have any block and tackle system and they say what is the velocity ratio, just count the number of ropes that form that block and tackle, and that gave me 6. So 6 is my velocity ratio. So I won't find that. I know that already. So I'll just say mechanical advantage is load over effort. Back to my solving. E is equals to load over effort over VR, which is 6, which I've seen is 6 in my drawing, okay, times 100. Okay, now we are trying to find what? We are trying to find E, which is my effort. Okay, so my effort is therefore going to become the subject or formula. Okay, so I will manipulate the formula now. So load over effort over VR, the effort will come down, giving me load times 100 over E times VR. Okay, now cross multiply, you'll be getting efficiency, capital E, that's my efficiency, times my effort, small letter e, then times velocity ratio times load times 100. Now making E the same means that efficiency and VR will go under load times 100. That will give me E is equals to load times 100 over efficiency times velocity ratio. So my E is therefore, what's my load in the question? The load of 120 Newton, that's 120 times 100 over, what's my efficiency? That's 40, and my velocity ratio is therefore from my drawing is 6. Now that will not be told you. You just need to know it from the drawing. Whenever you are giving a block and tackle system, if they draw it ever, if they ever draw it, know that the velocity ratio has been given to you automatically from the drawing. There is no calculation you have to make to get that. You just need to know, count the number of rope in the drawing, and that is your velocity ratio. I hope that's clear. Okay, so let's go on from there. So we have 120 times 100 over 40 times 60. Give me 120 and give me 12,000, please. 12,000 over 40 times 60 is 240. Divide that by 12,000, that will give you 15 Newton, and that is your effort. Now, don't forget the most important formula here is efficiency formula, and to remember the velocity ratio in every block and tackle system diagram. So my answer is 15 Newton, and that makes option D the correct answer. Okay, let's check out number 35 now. Number 35 says, in an experiment in which molten naphthalene is allowed to cool, the cooling curve in Fig 9 was obtained. Good. Now the temperature of 80 Newton, the temperature, please, 80 Newton, 80 degrees Celsius is known as what? Now look at that drawing very closely. Now the diagram shows you a temperature curve. This is temperature to time graph. So it is a temperature time curve or graph. Then you have, what this question is saying is that the temperature of the water is not increasing. The temperature of the water remains 80 degrees Celsius. That means you are boiling the water at 80 degrees Celsius. It is not increasing. Okay, now what happened at 80 degrees when the temperature is constant, but the time is increasing, but the temperature is not increasing, and the temperature ceases to rise at the boiling point of a liquid. Now, if you have water, when the temperature of water gets to 100 degrees Celsius, it will not rise again. It will remain the same. So the temperature of liquid get fixed at their boiling point. So the point, the 80 degree point is the point where the temperature of the water does not rise, and that is the boiling point. Now, if you say cooling point is that means the temperature is falling, it's getting colder, so the temperature has to go down. But boiling point, the temperature stands still, and that is what happens at the 80 degree Celsius temperature. Okay, good. So then melting, the temperature rise, because at melting point, when it's melting, the temperature, that's if you have ice and you are eating it, it will start melting, so the temperature is increasing. The evaporation does not have to do with temperature. Evaporation happens at any and every temperature. So the answer to that question is supposed to be, although I myself didn't check it well before, but it's supposed to be boiling point. Why? Because at the boiling point, the temperature of the liquid does not increase. The temperature remains the same. So sorry about that. So the answer to that question is supposed to be the boiling point, not the cooling point. Actually, the cooling point is the one sloping down. So I thought that the question is talking about the one sloping down. If ever the question asks you for the one sloping down, it should be cooling point because it's getting cooler. But at the fixed point, at 80 degrees Celsius, the temperature is supposed to be constant, and that means it is only constant at the boiling point of every liquid. It does not rise, it does not fall. It just remains the same at the boiling point, but it falls at the cooling point. I hope you get that. So that's the way the question should be answered. Now, don't forget to like the video if you really enjoyed the video, because we have more to show you from time to time. Now, even I myself, even though I went for the wrong answer in this question, I listened to the question and I thought, I was saying, okay, maybe, okay, the question is saying the one sloping down, but I didn't check whether the question is saying it's supposed to be 80 degrees. So that means the fixed temperature at 80 is not supposed to be the cooling point. The cooling point is the one sloping down, while the fixed one at 80 is supposed to be not A but B, the boiling point, fixed at 80. That teaches us a lesson. Always check the question well. Don't just run at the question and say, okay, from the drawing, I can see sloping down. So they are asking about the one sloping down. It's not the one sloping down. Check the question well so that you won't get it wrong. So the answer to that question, I'm just saying that now, is not the cooling point, because it's not the one sloping down that the question is asking. It's asking for the one that remains constant, and that is the boiling point. Option B. Now, if you really enjoyed this video, don't forget to like our page so that you can get more from us from time to time. Until we see next time, guys, take care of yourself. Bye for now.